So hello, teachers of exceptional classes. In this lab, you're really going to have 4 mini stations, and you will gather several pieces of materials which will be placed at the different stations. So you're going to have a meter stick, pencils, you'll have push pins, tape, balloons, tin washers, race car,
Beakers. Now we actually substituted the beakers. It says water bottles in the lab, but we didn't have water bottles, so we just got beakers, and we're gonna put a little bit of water in them, or in one of them.
And instead of the dollar bill, we used the typing paper.
Yeah, we're not that rich, so we just use paper. Also, you'll need a bendy straw, and so those are materials that you'll need for the lab overall. Oh yeah.
Okay, and you'll have to set up a ramp for your race car.
Let me show that real quick. So we have a ramp set up right here. Also, whenever you set up the ramp, we'll explain this a little bit later on, you don't want the ramp like set up super steep. We set up ours just a few inches off the ground. All right.
Okay, so as students visit the stations, okay, so with the wacky washers, you're gonna have 4 washers. You're gonna take your finger and you're gonna flick the 4 washers using that one wash, and you're gonna notice that what happens is that a washer is moved, and so an action is that an object at motion tends to stay at motion unless acted upon by an outside force.
Yeah. So this one, so this is Newton's first law. So these were all at rest, and then when we hit the one washer, since this was only one high, it only hit one washer, and so only one washer was acted upon, so only one washer moved, not the entire stack. And then we continue to demonstrate that. Next we're going to try 2. And whenever we do 2, make sure it's close enough here. Only 2 should move. Oh. If I flick it hard enough here. All 4 of them moved. I hit it 2. They might do that, but have them do it more than once if they do that. So, you gotta get it just right. See, 2 of them moved. The top ones just fell down, but 2 of them ended up moving after I got the 2 on there. And then you'll do it with 4. And whenever you do it with 4, of course, it's gonna look like just chaos.
Okay. Right. And then so for your second station, it's entitled mouth to mouth. You'll have 2 balloons. 2 bottles, and then you'll place your dollar. In this instance, we're using typing paper, and put the dollar or the typing paper between the 2 bottles, and in this instance, we use plastic beakers. Water is in the beaker just to keep it stabilized. And so now you're going to take the dollar, or in this instance, typing paper, and you're going to pull.
And we had to try this several times. You saw me move my paper and everything because this might spill some. So the first time that you do this, you want them just to do it nice and slow. And whenever you do it slow, you're going to notice that the bottle goes with it. And it just moves right along with it. That's because of friction. So once again, this is Newton's first law. As a force is acting upon the paper and friction is also acting upon this top one, it just moves. So both will move. Now if we do it rapidly, hopefully I can do it rapid enough. If we do it rapidly, that top one should stay on there. Here we go. Let's see if I can do a little bit of magic here.
Yes.
I did it.
Yes.
I think that only took 4 or 5 tries.
Yes.
So, good.
Okay, and then your third one is called Newton's race. And that's where you're going to have your meter stick for measuring distance. And because of the distance that we did when we did our trial, you might already want to have 1 meter measured off and then put your meter stick down a little bit farther so you get a longer distance. So if this is my 1 meter here, I might, in my lab, mark this as my 1 meter on my ramp, then I move it down so I can get more distance. Or you might already have it taped off on what the distance is. So if your car moves back a farther distance, you'll know what that is without having to go back and measure. You already know it makes it that distance is 2 meters. And then all the students will have to do is just do from that point on. Just depends on how much time you have in your class.
All right, and another thing you do if you wanted to is you just measure from where it stops, where the ramp stops, and then you just go measure from there as well. So just whatever setup works best for you. So the students can bring in a matchbox car here. Now what we've noticed as we try to do this one is it tends to swerve off one side or the other. So it works, it just takes a lot of trials because as soon as it swerves, you're losing some of that force, and so it's not the best, but if that's all you have, then just make sure that they only calculate the ones that go in a straight line, not the ones that curve off to the side. What we're going to try to get for you is these actual, I forget the name of these cars, I think they might actually be called like Nunez cars, but these are super low friction and these work great for the experiment. And on this demonstrates Newton's second law, force equals mass times acceleration. The acceleration in this case is gravity, which accelerates at 9.8 meters per second squared. Now, since we have a ramp, we're not getting that full 9.8 meters per second squared, but that's the acceleration is constant. And the only thing that we're going to manipulate is the mass, and so each time we're going to get a different force. That force is going to be reflected in the distance that the car travels. And so whenever we do it without any mass in it, and I'm going to start lower just so you can get the entire picture. It only goes about a meter, and then I'm going to take 5 washers, and I'm going to place 5 washers in there. Whenever I place 5 washers in there, it's going to go further, and it only went a little bit further, but it did go further. And you're going to do this multiple times. So the students get good data, and then I'm going to take the final 5 washers to give me a total of 10, and then I'm going to run that trial, and that's going to go the furthest distance because it has the most mass, therefore the most force in the end.
All right. Our third,
Yeah,
what's the third?
Our fourth lab.
Our fourth lab is entitled Balloon Rally. So you'll need balloons, and you'll need your straw, and you'll need your push pins. Okay, and so what you're going to do then is attach your balloon to the end. We use tape to attach it, and prior to this, Jake had been manipulating this, so we're going to let him do the demo because he's already blown into the straw. And so,
I don't know what that's
is
about.
it okay? Just help. Just help issues. And so you're going to attach a balloon to the end of the straw. He's already done that. And the second step then is to push a straight pin through the straw, about halfway between the balloon, and then bend the end.
Yeah.
And you fasten it to the eraser of the pencil. So the next step that the students will perform is to blow up the balloon, and you're going to have it bent at a 90-degree angle so the air, allowing the air to escape.
I'll get that in a second. One thing that we learned is that whenever we first started bending the straw, this is all Dorothy's fault. She was doing it upwards, and I was like, no, Dorothy, it's not supposed to be that. So whenever we did it, we were doing upwards and nothing was happening. We're like, something's wrong here. And then we figured you're actually supposed to turn it sideways so that it's perpendicular to the pencil here. And so we turn it sideways, and that's how we got the result that we want. So whenever you blow it up, and you turn it 90 degrees, and you see it move. And then what's the second angle?
The 45-degree angle is the second angle. So he's going to blow it up and then bend at a 45-degree angle. And it sort of moved back out in its place, so you want to make sure tell the kids to make sure they do as best they can in bending it at a 45-degree angle. And then the third one is 180 degree. And then release it.
Doesn't really move. All right. And then what's
And
the
then you're going to move the pin and hold it on the straw and then blow it up. And release the straw.
Kids are gonna love that.
Yes.
They're gonna love that.
Okay, and along the way on that data sheet, they would be recording responses either in written statements to the different stations, or they will be recording inside their chart that is given for the Newton's race. And there are questions that follow that they have to explain what it is that what is that happened and which law it is.
Yeah.
Okay?
And the balloon rally would demonstrate the third law: for every action, there's an opposite and equal reaction. So as the air was pushing out one direction, the balloon was forced the other direction. That's why with the 180, it wasn't going anywhere, because it wasn't like it was able to spin around, because it was just going in a straight line, and the pin was holding it in place. And once we took the pin out, it was able to move, and it just kind of moved randomly because there was no fins. Yeah, that's it.